Hello, good afternoon, everybody. Hello, good afternoon. Can you hear me? Hello, good afternoon. Can you hear me, please? Please, if you can hear me, can you just turn on your mic and talk to me, please? Hello, class. Can you hear me? If yes, can you please talk to me also, please?
Good afternoon, sir.
Okay, good afternoon.
We can hear you.
Can you hear me now? Hello, can you hear me properly? Hello?
Yes, sir, we can hear you.
Okay, thank you very much. Thank you very much. We are welcome to today's class. This
Yes, sir.
okay, you can hear me. Okay, good, good. And you can also see my screen. Can you see my screen? Can you see my screen also? Can you see my screen? Please, I want us to respond. It is very, very important we respond to me. Okay. Before we go into this class properly, this is a fundamental introduction to artificial intelligence. So my name is Ajayi Ebenezer. I will be taking this session for
Yes.
okay. I'm Ajayi Ebenezer. I'll be the one
Yes, sir, we can
taking
see.
this section for this trimester, and is introduction to artificial intelligence. And I want us to resolve one or two things before we proceed into the class. You can see my screen very well. These are the lecture schedule, and we can see from there that they have about 3 or 4 public holiday. On the 10th of August, which is next week, is a public holiday. 31st of August is a public holiday, and also 19th of October is also a public holiday. So in 12 weeks we have about 3 weeks that we are going to have a public holiday. So I want us to resolve it, the time we can be able to hold this class. I think, can we hold this class that same day? Because we have public holiday on Tuesday, can we bring it to Monday, or can we take it to Wednesday? I want us to resolve that before we go into the class proper. It is very, very important. When do you think you can do this lecture? Since we have a full house now, I think we have about 41 in attendance. So I want us to quickly resolve that. When do you think we can reschedule the meeting so that we will not miss any of this meeting? Hello class, please, can we talk? We really need to resolve that. Or can we do it a day before or a day after? Sorry, I want the class to respond. Hello, can you hear me?
Which
We have like on the
on
10th.
the 10th.
So we are going to
So
have
we are
it on
going to have it
Wednesday,
on Wednesday, which is
11th of
11th
August,
of August,
between 3
between
and
3
5.
and 5.
Also,
Also,
the 31st
the
of
31st of
August,
August,
which is
which
Tuesday, we
is
are going
Tuesday,
to
we are
have
going
it
to have it
1st of
1st of
September,
September,
3 to 5
3 to
p.m.
5
also.
p.m. also.
Then
Then
the one of
the one of
October
October
19,
19,
we are going to
we are
have
going
it
to have it
October 20,
October 20,
between 3
between
and
3
5
and
also.
5 also.
Is it taking?
Is it taking?
Sir, I'm sorry, but on Wednesday I have class. I have lab from 3 to 5.
Okay.
Okay.
Okay. So
Okay.
if there is
So
going to
if there is
be a
going to be
change
a change
in the
in
what we have
what we
done,
have
maybe
done, maybe
we'll discuss
we will
it in the
discuss it
class.
in the class.
But maybe
But maybe
tentatively
tentatively
we should just have
we
it
should
like
just
that,
have it
right?
like that, right?
Sorry, can you repeat it?
I said
I said
tentatively,
tentatively,
can we have it
can we
like
have it
that?
like
That
that?
is the
That
one
is
of
the one of
10th of
10th
August
of
should be
August should be
done on
done on
11,
11,
3 to
3 to
5,
5,
and then the
and
one of
then the one of
31st
31st
should be
should be
done
done
by
by
1st of
1st of
September,
September,
3 to
3
5,
to 5,
and then the one
and then
of
the one
19
of 19
October
October
should be
should be
done
done
by
by
20th of
20th of
October,
October,
3 to
3
5
to 5
also.
also.
Should we do it like that?
Is it on Wednesday or Thursday?
You said?
You said
All of them are
all of them are
Wednesday.
Wednesday.
Wednesday I have lab from 3 to 5, another subject.
Okay,
Okay, you have
okay. What of
okay.
other
What of
people?
other people?
I'm sorry, sir. I suggested before the class.
Okay.
Okay,
We should
we should
discuss it.
discuss it.
Okay.
Okay.
I also have
Okay. Okay.
Okay.
on
Okay, no
Wednesday
No
and
problem.
Thursday. The Monday is 3 to 5 Monday.
Okay, your
Okay, your
Monday is
Monday
free.
is free.
Yes, 3 to 5.
So how about Monday we do it on 8 to
Mon-
4? Because 4 to 6 be a class.
When?
When?
Okay.
Okay.
Yes, sir.
What of
What of
Saturday?
Saturday?
What of your
What of your
Saturday?
Saturday?
Everybody's
Everybody's
Saturday
Saturday
is
is
free.
free.
Thursday maybe 3 to 5.
Thursday I have class 3 to 5.
Okay.
Monday would be
Uh,
3 to 5.
Okay.
Okay.
So
So how about
what of
What
our
about
Saturday?
Saturday?
Not Saturday.
Okay, you have
Okay, you have
class
class
on Saturday
Saturday
too.
too.
So how about we do it on Friday?
Okay. Yeah.
Okay. So what
So
of
what of
Friday?
I have class.
So
So
it
it
seems
seems we can really
to
come
a
to a
term
term
now,
now,
right?
right?
Okay.
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 Maybe
As
as
the
the
time
time of food
itself,
itself,
we should
we
be
should
able
be
to
able
know what
to
to
know
do,
what to do,
right?
right?
So we
So
should
we should
wait
wait
until
Our replacement classes would be from 8 p.m. the next day, so
8
8
p.m.
p.m.
the
8 p.m.
next
the next
day,
day,
8 to
8 to
10.
10.
Is it all
Is
right
it
by
alright by
everybody?
everybody?
That's the
Sir,
classes.
what is the next day? She mean is Wednesday or?
Wednesday.
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 I'm sorry that to inform because Wednesday 9 a.m. we have another class.
Oh my
Oh my
God.
God.
Yeah.
9 p.m. No.
So I suggested maybe everyone propose their timetable, then you
No,
can
no,
take
I have
consider.
9 a.m. You have class at 9 p.m.
Sorry, 9 a.m. It's 9 a.m.
Okay, 9
p.m.
9
not
a.m.
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 So we are
So we
talking
are talking
about
about
PM.
PM.
Yeah, 8 p.m.
8
8
p.m.
p.m.
Is
Is
it
it
all right
alright
by
by
everybody?
everybody?
8
8
p.m.
p.m.
to
to
8 to
8 to
10.
10.
8 p.m.
Agree by
Agree by
everyone.
everyone.
By everyone. 8 p.m.
By everyone.
Wednesday.
8
I
p.m.
think yes.
Wednesday.
Yes.
Yes, 8 to 10 p.m. on Wednesday would work, I think, for all of us.
8 p.m.
8
right?
p.m. right?
Yes, 8.
Okay.
8
Okay.
p.m.
Thank you so
Thank you
much.
so much.
Thank you so
Thank you
much.
so much.
Sir, but how about Friday?
But some people
Some people
said they
said
have
they have
class on
class on
Friday.
Friday.
Morning?
Friday morning.
Friday morning.
Do you have class?
Do you have
Yeah.
class?
Definitely
it's hard
no.
for us.
No class, no class.
Yeah. No, but it's like the moment, and we are international students. There is different time zone.
Okay.
I think Wednesday night will be better for all of us. It's possible.
Okay.
Okay,
International
international
students.
students.
Night
Night
will be
will be
best time
best
for
time for
them.
them.
Yes, because it would be 3 p.m. here, 8 p.m.
Yeah.
there, 2 p.m. Works for us.
Okay.
Okay.
So
So
can
can
we
we
help our
help our
international
international
students
students
so that they
so
be
that they be
able
able
to
to
attend all
attend
this
all
course?
this course?
Because
Because
like
like
now
now,
if
if
you
you
say
say
8 a.m. in the
8 a.m. in the
morning,
morning,
it's going to
it's going
affect
to
them.
affect them.
Because that
But
time
that
will
time
be
will
a kind
be
of
a
a
kind of a
midnight.
midnight.
Yeah.
Yeah.
Like if you
Like if you
fix
fix
Friday
Friday
morning,
morning,
that time
that
they will
time they
still
It
be
will
would
still be
sleeping.
be
sleeping.
Friday morning. It would be like 3 a.m.
Yes.
Yes.
No, I don't
So
know.
So
if we
if we
can do
can
it
do it
between
between
we can do
we can
it
do it
8
8
p.m.
p.m.
on
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 Wednesday.
Wednesday,
I think
I
it will be
think it will be
convenient for
convenient for
everybody.
everybody.
Yeah, because no
Yes,
one have
8,
class, and
8
it's
p.m. is
the
perfect
best
for
time
us.
for all of us.
Yeah, it's not too early. It's not too late for us, for you guys, and not too early for us. I think it's the best
Okay.
time.
So
So
uh,
I
can we
can we
say
say
8 to
8
10
to 10
p.m.
p.m.
Wednesday
Wednesday
for
for
all the
all the
courses that
courses that
fell
fell
all the
all the
time that
time
fell
that fell
under
under
the public
the
holiday.
public holiday.
Yes.
Okay.
Okay.
Thank you so
Thank you
much
so much
for
for
your
your
understanding.
understanding.
So I think we have been able
So I
to
think we
clear
have been
this.
able to clear this.
So let's go
So let's go
straight
straight
into
to
our class. Let's go straight into our class, and I believe everybody can hear me properly. So we want to look at into LISP, and we all know that the course we are taking this time around is artificial intelligence fundamentals. Artificial intelligence fundamentals. So we are going to talk about LISP, which was one of the programming language we are going to use. We're going to talk about Prolog, which is one of the programming language we are going to use. And so today we want to look at introduction to LISP. That's the first thing we are going to study today. We want to look at how to go about it, how to program it, and how to have one or two things to do with it. And at the end of the day, we are going to have an assignment, which a programming assignment, which we are going to use LISP, and then we make use of also Prolog to handle at the end of the day. Then that will be presentation. You are going to divide yourself into group, at least a maximum of 3, minimum of 1. So but it is very, very important that you have a team member. So when the time comes, we are going to release the assignment, and also we are going to make a Google form available and a SF form available, Google Sheet available, where we can put in our time and our time slots, so that we'll be able to know when to do it. And all other announcements as regards the assignment will be made on our MMLS. So please try to look at your MMLS. Any information there as regards this course, it is very, very important. The coordinator of this course will be pumping in some information for us every time we have any information about the course. But this morning we are going, this afternoon rather, afternoon in Malaysia, and then it may be morning in other places and also night in other places, but we're in the afternoon in Malaysia. So we want to look at the introduction to LISP. So, and the first thing we are going to look at is that we are going to make use of Allegro Common LISP for the implementation. So the first thing we are going
so you are not sharing your screen.
okay, you're not seeing my screen. Sorry. Okay, sorry. Can you see my screen now? Theo, can you see my screen?
Yes, sir.
Okay, it's coming.
Yes, sir.
No.
It's coming.
Yes,
It's
now
still
it's
coming. Okay, you can see it now, right? Can you see the
yes.
screen now? Okay, good. So you can see the slide.
Yes, sir.
Okay, so we have a lot of resources for LISP, and the first thing is to install the LISP we are going to use. So I want you to copy this, the first link on your system. Can you just copy it and then try to download it? Allegro LISP download. So you copy it and then go to your browser. Then you try to install it. You download it and install it, because from there we are going to be doing our programming. So I'm coming. Okay, so you click on this Allegro CA download. Can you see my cursor? Can you see it? Are we together? Hello class, are we together? Hello? Hello class, are we together?
Yes, sir. Yes, sir.
Okay, okay.
Yes.
Please, I want you to be responding so that I know that we are together on the same page. So,
Yes, sir.
okay, good. So let me go back. So you just click on this to download, and then after the download you try to install it, and then when you install,
Yes, sir.
okay, come to stats and then look for it. Look for, you can see Allegro CL, and then you click on Allegro CL 10 Free Express. Then you should have something like this. Still coming.
Yes.
Okay, so after the installation you should have something like this on your screen. Do you have this screen? Did you have this, something of this nature on your screen? Do you have something like this? Do you have something like this, CG-user1? Do you have something like that on your screen?
Sir, one more question. Which one are we supposed to download again? Is it?
You download this.
Sir, is it?
You download this Allegro CA download.
Yeah, I have the Francis.in screen. Which one is it? The
What do you have? When you click on download, it will show you. Okay, let me try to download this. Just hold on, it's still coming. So you should have something of this. So you click on agree. You click on agree. You agree to the license. Then you enter your email. And then you supply all this information. And then you click on submit. Have you done that? Have you done that? And what did you see on your screen? You put in your information, you agree, you put your email address, and okay, let me try to do something for you. I've installed it before, so I don't want to reinstall it again, but let me just do something like this. Okay, I don't want them to be sending me email, and these are optional information. You may put it, you may not put it, just an optional. Then you click on submit. When you submit, then it will give you this. Can you see it now? Hello, can somebody talk to me, please? Are we together? Are we on the same page? Hello, class. Do you have this screen? Legian, do you have this screen? Theo, do you have this screen? Alfred? Oh my God. Sorry, I lost the connection again. So, do you have this screen? Let me share the screen again. But you should have this screen on your screen after the presentation, after the downloading rather. Since after filling up your information.
I can't see the screen, sir.
Okay, I'm coming. The screen is coming. Can you see the screen now? Can you?
You're still not presenting.
No, sir.
Okay, hold on.
Still nothing appears, sir.
Okay, just hold on. But I think it's coming.
Maybe because your connection
Yeah,
is slow.
I have an issue with connection, but I think it's coming because it's showing me that I'm sharing. Okay, let me stop sharing and do it again. Okay, so let me share again. Okay, so you should have something like this, and then you pick your operating system. If it is Windows Vista or newer version, you click on this. If it is Linux, you click on this. If it is ARM Linux, you click on this. If it is Mac, you click on this. And if it is FreeSBS, it's also for Linux, you also click on this. So it depends on what you want to do. So it depends on your operating system. If your operating system is Windows, just click on this. If your operating system is Linux, click on this. If your operating system is Mac, you click on this. Is it clear? So any of the operating system that you have, we should be able to do that. Then after the installation, you should see it on your start button. Let me share that area so that you'll be able to see it properly, because this is what we are going to use for the programming aspect of the work. Let me share the entire screen to enable us. So can you see my screen now? It's still loading, right?
No, sir.
I want to load the entire screen now. Okay.
Yeah, now can see.
Okay, now can see
your screen.
Okay, good. So now you should go to, if you are using Windows, because I'm using Windows. I don't know what other people are using. I'm using Windows, so you should see something like this.
Yeah.
Allegro
Can see.
CD 10.1 Free Express. You click on it, and then you click on Allegro this. When you do this, when you click on this, you should have something of this nature. If you have this, let me know. Just say yes. You have. Do you have this screen? Did you have the screen I just showed now? Hello, Cole? Did you have that?
Yes, sir.
Did you have this type of screen? Did you? That says CG-user 1.
Yes, sir. Yes.
Okay, you have
Yes,
that. Okay,
yes.
okay. Majority have. Okay, good. So this is the
Yes, sir.
the programming language we are going to use for this course. We call LISP. This is what we are going to use. And so along the line, we begin to do some practicals. I begin to do some programming, and then just try and follow. So that's that about this. So the next one, the next slide. So LISP is being invented by John McCarthy in 1956, and is partially based on Lambda calculus and is regarded as the language for AI. Normally, we have two dialects of LISP which are widely used today. We have what we call scheme LISP, and then we have what we call a common LISP. So if you are doing a small project like the one we are doing now, small project like you want to write a little program, so you can use a scheme LISP. But if you are doing for industrial application, you want to build a big application, you use what you call a common LISP. And then we'll basically look at the feature of a common LISP. Is a machine independence, that is, irrespective of the operating system you are using. It is a kind of a cross platform, and that's the reason you have for operating system, you have for Linux, you have for Mac operating system. It is used interactive design methodology and easy extensibility, so you can easily extend it. It's a kind of an iterative design, and then you can easily extend it. Also, it allows updating the program dynamically. Like when you are doing your programming. When you are programming, you can make some changes, and then you run the program again. It accepts that. Then it provides high level debugging. It also provides advanced object oriented programming. I believe you know what we call object oriented programming. So it provides advanced object oriented programming. It also provides a convenient macro system. Enable us to write some macro, and then when you write the macro, and then you can run it conveniently. It also provides wide range data type like object, structure, list, vector, adjustable array, hash table, and symbols. And also it's expression based. It also provides an object-oriented condition system, and then it provides a complete high-ho library, that is input and output library. It also provides extensive control structure, that is when you want to move from one section of your program to the other, LISP enable you to have such thing. Then also application built in LISP are Emacs, G2, AutoCAD. The AutoCAD you see today that we are using today is based on LISP. Then we have what we call Eagle Engraver, and then the Yahoo store. The big Yahoo store we see today, they are all built on LISP. So these are some of the area of application of LISP. It has been successful. A lot of people have been using that. We all know the Yahoo store. We all know AutoCAD. So they are all patterns based on Lisp. They are all pattern based on Lisp. So running agro common Lisp, we have two modes. We have what we call the IDE mode, and then we also have what we call without IDE mode, which is ANSI compliant. So only the interpreter is present. So for this course, majorly we are going to run in it without IDE. Though what we have also make up of IDE, but we are going to make use of without IDE, and that's the reason we have this. So we can enter our commands here, we enter our instruction here, and then we get it done. And we know the structure of Lisp is that everything is being put together in a bracket. Everything is put together in a bracket. So if you open a bracket and close it, all the instruction needed in Lisp will be put here. So as we progress in the class, you will see what I'm trying to pass across. So we all know how to get there. You click on Start Program, Allego CS 6.0, and then you click on that thing. You should be able to have what I have here. You should have what I have here. So let's take, for example, we want something like this. Let's say you want this at the prompts. You just come here, put it here. I told you is a kind of a program that's being embedded in a bracket, open and close brackets. All the information will be there. So what we have here is a command, call it append, and then we have a column here. One, open another bracket, that's another list. One, and then open another bracket also. We have 2 to 3. 2 and 3 is a list. Then 1, then that small list, and then 4 is another list. Before we have the outer open and close bracket. So if you press enter, you see what will happen. You can now see it. We have 1, then 2 to 3 inside a list, and then we have 4, which is now we have open a bracket. We have a list. Now we have a list inside a list. So the first list is 2 and 3, and then the bigger list is now 1, and then the sub list that are made up of 2 and 3, and then the last number, which is 4. So this is how to run a program in Lisp. So as we continue in our study, we can see how to write a good and a better program. So let's just continue, and then when you are done, you want to exit, you just type exit, and then you log out of the place. You type exit, and then you log out of the place. So if you want to try it, let's try it and see how it look like. You just do exit, and then you close the bracket, you press enter, then it take you out. Of the program. So let me go back again. So that's how we can start Allegro CL free edition, and then how to close it. And so that's how to start it, and that's how to close it. When you want to start, you click on start, you locate where the folder is, and then you click on the executable file of it, and then it will something of this nature. And when you are done with your programming, you just open a bracket, you type exit, and you close it, and then you press enter, and then you take it out of this place. So let's continue. So there are 13 things we need to know about LISP. We are still trying to lay the foundation. We are still trying to lay the foundation for the LISP. So we are going to get to know some things about LISP. We are going to get about to know about LISP. So we have about 13 things we need to know about LISP. 13 things we need to know about LISP. So the first one is that LISP is a symbol manipulation and list processing, and as a matter of fact, the LISP stand for list processing. The LISP itself is what we call stand for list processing. Stand for list processing. So the first thing we need to know about LISP is that LISP is a symbol manipulation and list processing. So we say list stand for list processing. So extremely easy to manipulate list and symbol using LISP, and the most important data structure is list. I told you, you have it like this inside in open and close brackets, inside open and close brackets, inside open and close brackets. So all the information you need to put, all the programming lines you need to put, it has to be inside that open and close bracket. And then the number 2 thing we need to know. Yeah, I'm listening.
Are you not recording?
You said?
Are you not recording?
I'm doing that.
You're not gonna record the lecture?
I'm recording the lecture, so you can have the recording later.
You are?
Yeah.
Okay, thank you.
Yeah, you can have the recording later. The coordinator will post it. I'm recording it already. So the second thing you need to know about LISP is that it is a bottom-up programming. It is a bottom-up programming. So you don't just write your program down towards the language. You also build the language up from your program. So what we are trying to say is that when you're talking about a bottom-up programming, the little task, the small tasks is being put together to form a big task, and that's what we call a bottom-up. So you grow from the bottom to up. You grow from the bottom up. So it's different from a top-down approach. A top-down approach is when you have a bigger or a complex program being subdivided into sub-components. But with the LISP, we have the sub-component be put together to form a complex program. And that's the reason we call it a bottom-up programming. We call it a bottom-up programming. And at the end of this program, we are going to see how we are going to write a good program that will reflect bottom-up programming. So we have subcomponents of our program, which we are going to put together to form a complex program. So the third things we need to know about LISP is that LISP is interactive. LISP is interactive. We have what to call read, evaluate, and print. We have what to call read, evaluate, and print. So it contains an interpreter that evaluates your input first. You will need to look at what your input is all about. It's going to evaluate them one after the other. The interpreter will evaluate them, we read them, and then later evaluate, and then it will now print it out for us. So it contains an interpreter that evaluates what you input. The interpreter is commonly referred to as a listener or evaluator, or a top level or read, evaluate, print loop. So what it does is that first it therefore read all your inputs, and your construct of an expression. It will read it one after the other, and then the next thing it does is to evaluate the expression for meaning. It will evaluate the expression for meaning, and at the end of the day, you will now print your output. It will print the result of the evaluation or signal and error if the input was incorrect. So there are three things the interpreter does, you first of all read the input and the construct an expression from it, and construct an expression from it. Rather, sorry, it will read the input and then construct an expression from it. Then after that, it will evaluate the expression for meaning, and then after the evaluation, then it will now print out the result of the evaluation. And if there is a problem with the program, it will signal error. If there is a problem with the program, it will signal error. So LISP is interactive. You will see if there is a problem along the line, you will see, it will tell you, it will signal error. If you have an error with your input, it will tell you that is an input error. So it is being developed in such a way that is very, very interactive. So you may not lost along the line. If you have error on your program, you will simply know. You will simply know if there is an error on your program. You will simply know because LISP is interactive. LISP is interactive. So the fourth thing we need to know is that LISP is dynamic language. You know, when we are talking about dynamics, it's something that keeps changing. It can change. It's not static. It's not static. It can change. A little change you make to it will change or will affect the result of your program. So it allows. It is a kind of a program. Is a dynamic in nature. The LISP is a dynamic language. Is a dynamic in nature that whenever you affect or whenever you make a changes, it will be reflected on your code immediately, and your result will show it. So the program has developed incrementally by making small change to the source code, and as soon as you make changes to the source code, the interpreter evaluate the changes definition and then immediately run the result. So it's not static that the program will be say okay, it does not accept changes. So it accepts changes and then the result is being updated immediately. The result is being updated immediately. So they have what we call a new definition, and data structure can be added to LISP at any time. So you don't wait until when you finish coding. Anytime you think or there is a need for you to change your data structure, or there is a need for you to have a new definition, just input it immediately, create such data structure immediately, and it will be added rather, sorry, to your LISP, and then it will take effect immediately. And also this feature we are talking about is an idea for prototyping. When you want to develop something, you want to have a prototype of a system. You want to have a prototype of a system. This dynamic in nature help you to do that, because there is a lot of changes you need to make when you are trying to build up something, when you are trying to come up with a prototype. There's a lot of things you need to put in place. A lot of things have to change. When you do it and it didn't work the way you want it, you can change it to make it work the way you want it. So dynamic in nature is one of the property of LISP. Then the fifth thing you need to know is that LISP has symbols. Symbols are basic type of data in use. Symbols is one of the basic type of data we use in LISP. So symbols are used to build up a bigger or a more complex expression. And a symbol is a sequence of character like hello. We combine a lot of characters together, HELLO, or it can be integer be mixed with character. So it can be character alone or strings alone. It can be alphabet alone, let me put it in that way, or it can be alphanumeric. It can be either alphabet or alphanumeric. Then you join numbers with a character or with alphabet. So symbol is one of the data type we use in LISP. Are we together? Are you with me? Are we together? Okay.
Yes, sir.
Okay, good. That's okay. So let's continue. Let's continue. Then the system we need to know in Lisp is that Lisp has a list. I've already explained that in the beginning. Say it starts and end. The start and end point of a list are delimited by left and right parentheses. Just like what I did when we started here. I told you you have this left and right parentheses. So everything you want to code is inside the left and right parentheses. So the start and end point of Lisp is using the right and left delimiter. Is using the right and left delimiter. So or it's right and left parentheses rather. Sorry, you're making use of right and left and right parentheses. And anything can be placed in a list, including other lists. So we call it a nested list, just as we see it in the example I gave last time. So a list of 3 elements, an integer, a symbol, and a floating point. You can see it here. The first one we have here, for example, we have 1 is an integer. We have ZZ hyphen top, which is a symbol, and then we have 56.7 as a floating point. Let's see how it look like. It's just an example of a list that contains 3 elements. So like now we can have it like this. Let me delete this. So we have an integer 1, we have a symbol which is ZZ hyphen top, then we have 56.7 as a floating point. And the beauty of this is that you don't separate it with comma. We only leave a white space. When you type the first character, let's say for example, let me do something. Let me delete this. You see the first column. Let me do it like this. So you put 1 here, then you press a space bar. You see ZZ top. Then you put another space. Then you press 56.7. So this list contains 3 elements. 1 is an integer called 1. The second one is symbol, which is ZZ hyphen top, and the third one is a floating point, which is 56.7. So if you run it, sorry, there is an error there. So okay, sorry. Errors keep opening. So let's continue with our lecture first. So, but the most important thing is that we have 1, which this list contains 3 elements, which is 1 and a symbol ZZ hyphen top, and then 56.7. Then we have another list. This example shows about 2 elements, a floating point number and a list. The first one is 4.5, which is a floating number. Then another sublist, which is 3 blind and mice inside the bigger or the big list. So we can see this. First, this is small, is a sublist, and then this is the bigger list. So in this type of example, we have 4.5, which is a floating point as an element of this list, and then we have another sublist. So in the bigger list, we have 2 elements. We have a floating number and then a sublist. And in the sublist, we have 3 elements. The sublist has 3 elements. The first one is 3, the second one is blind, and the third one is mice. And then also a list of no element is also called an empty list. So when you open a bracket and close it, is an empty list. It is an empty list. So caution, elements within a list are separated with a white space and not a comma. It's a white list and not a comma. A white list and not a comma. So the 7th thing you need to know is that list classify data. List classify data. So it does not classify variable, rather it classifies data. So a variable can just be a symbol and it can hold any value, or it can hold any type of value. So a variable does not even need to be declared before it is being used. So a variable does not need to be declared before it be used. So leave this, define different type of data rather than defining different type of variable. So it define data rather than a different type of variable. So new data type may be dynamically added at any point in the development process. So leave classified data, it does not classify variable. So the 8th thing we need to know is that leave classified data, not a variable. So you can see the list expression, you can see number, it classifies number as integer, float, or ratio, and then it classifies symbol as keyword, and then it also classifies sequence as list or vector, and then vector can also be subclassified into strings, and that's the reason we have integer, a number containing like 100 or minus 23. We have float, a real number like 1.23 or negative 32.0. We also have a ratio, a fraction like 99 divided by 100 or 3 divided by 2. Then we have symbols, a sequence of alphanumeric character like F00 or I34. Then we have keywords, symbol like prefix with a column like column full F00 or column high 34. Then we can have list, a group of zeros or more expression inside an open and close bracket, inside an open and close bracket. Then we also have what we call a vector. A vector is one dimension group of an expression in a sequential memory. And then we can also have a strings, a vector of zeros or more character inside of double quotes, inside a double quote. So when you have information or when you have a character inside a double quote is known as a strings, just like double quotes F00 and then you close it. So whatever you do at the beginning, you are going to do it at the end. If not, you are going to run into error. You are going to run into error. Then the next one is 8th thing you need to know is that lists use previous notation. Previous notation, I don't know whether you've done something like compiler construction. There will make use of some of these things, some of this notation. So in lists we make use of previous notation, that is, you have the, here we call it symbol, but in other programming language we call it operators. So we have, say, previous notation means that operators appear in front of their operand. Operator appear in front of their operand. Like in all other programming language, we have the implicit expression, which you see, if you want to add two numbers together, you say maybe a plus b or 1 plus 2. But in Lisp, we make use of operator first, then 1 and 2. If you want to carry out addition, that is to say 1 plus 2, you have to first see the operation first, then 1 and then 2. And you know, Lisp is very, very close. I don't know whether you've seen assembly language before. I don't know whether you've talked about assembly language before or machine dependent code. So Lisp is very close to machine language. This is very close to machine language because with this, and that's the reason why one of the features we talked about that we talked about at the beginning, that is if you look at the code, is efficient you can run it with a maximum speed, because it does not really look at the other program, like the all other programming language. It's very close to machine language like now, so it's kind of a previous notation. You see the operator first, and that's the reason when you look at the one of the things we need to know, that we say it will first of all read your it will read your input. It will the interpreter will evaluate it, and then it will now print out what we call, it will now print out the answer. You can see the first thing it sees is that, okay, this person or this code of line want to do addition, and then the next thing you need to look at, okay, what are the inputs? It will straight go to this place. Okay, 1 is an input, 2 is also an input, and then okay, then you will now add 1 and 2 together, and then it will give us it will provide the answer. So this is how LISP work. This is how it works. So another thing we need to know, the ninth thing we need to know, is that LISP is a functional language. It is a functional language. So as a general LISP function, it will take a data, calculate with it, and then return the result. It will take the data, calculate with it, and then return the results. So the first thing you see is the operator, the addition in case of addition, plus, and then it will look at the data 1 and 2, and then it will calculate with the data, and then it will return the result. So the result returned by a function are called function value. The result returned by a functions are called function values, and then a function can return any number of values, and when more than one values are returned, they are called multiple values. So a function can return any number of values, and when more than one values are returned, they are called multiple values. Another thing we need to know, just like this now, so LISP is a function language. To call a function, place it at the first element of an input, list followed by its operand. For example, you can see the addition, then 3, 4, 5, 6. What this does is that it will put all of them together and say 3 plus 4 plus 5 plus 6, and then it will return the result. So call the function f. I told you here we'll call all this operator a function. So we call it will call the addition function. It will call the addition function and passes the number 3, 4, and 5 and 6 to the function, and then the addition function will then add the numbers together and return the value 18. Let's try to see what we are trying to say here. You see, we say here plus function space 3, 4, 5, 6, and then we close it. We close the bracket, and then we press enter. We can see it returned 18 to us. Can we see it? Are we together?
Yes, sir.
Okay, so you can see that it returned the value 18. It returned the value 18, and what did it do? The function addition is there, and then the input was passed to that addition function. So the interpreter will call the function, the addition function, and passes the number 3, 4, 5, 6 to the function, and then the addition function will then add the numbers together and return the value of 18. And this is what just happened here. This is what we just seen here. We can see it here. This is what just happened here. So 3 plus 4 plus 5 plus 6 is equal to 18. So let's continue. That's one thing we need to know. And then We can also have this, say, in most languages, programming a mixture of calling and not calling component. For example, the C statement, S is equal to 2 plus guess some number. So, contain a call to procedure named guess some number, but the assignment of the S variable and the addition of 2 had hardwired into C language. So this is a C language. We say C, S to be equal to 2 plus guess some number. So guess some number is on its own, is a procedure. It's a procedure, but the assignment of the variable S and the addition of 2 are how hardwired into C language. But let's see further. Sorry. So, but Lisp is a functional language. The same statement will be implemented in Lisp by calling the tree function, rather than the way it is being called in C or C++ or in any other programming language. Lisp is a functional language. So the same statement will be implemented in Lisp by calling tree function. The function is set to assign the value of S a value. Then 2, the function addition to perform the addition, and the third one is the function called guess some number. The function called guess some number, and then the whole statement will appear as a nested list. And you can see the way it is now. Set f s, that is, you first of all set the value for you set the value just like you want to assign all the answer or the what we have, the value from 2 plus other get number, we assign it to S, and that's the reason we have what to call set fs, and then you open a bracket plus, which is a function, addition function, then the number first 2, and then you also have another sublist. So here we have 2 sublists inside a main list. The first sublist is the one that contains the addition function 2 and then the number we are going to get. Whereas guess some number also is a list on its own. It can be 3, it can be 3 elements, it can be 4 elements, it can be 5 elements, depending on what you want to do. And so in general, in the bigger list, we only have 3 elements. We only have 3 elements, and inside the sublist we have 2 elements. We have 3 elements also. The addition function, the first input, and then get some numbers input. But the last one, the last list, we don't know the number of input that is there, but we know that it's going to get some number. It's going to get some number. So we can translate this expression into English expression like this: the value of setting S to, the value of adding 2 to, and then the value of getting some number. The value of getting some number. And then, just as we are saying, we say Lisp is a functional language. As you say, given an expression, how can we tell what is a function from, and what is not? So since Lisp uses a previous notation, we know that the first element of each list in the input expression should be a function, either an operator or a self function. Like this, you can say therefore set f, comma, plus, and get some number are functions. Set f, that is the initialize, what initialize the value to S is a function of its own, and then addition is a function of its own, and then get some number is also a function. So conversely, S and 2 are not the first element of any list, so that they cannot be interpreted by Lisp as a function call. We are still referring to what we have earlier. And so the 10th thing we need to know about a Lisp is that a Lisp makes no distinction between program and data. It does not make any distinction between programs and data. So how can this be? So program are function, and function are just list of instruction for doing something. So programs are function, and functions are just list of instruction for doing something. So in Lisp you can have function of function. So a function really has a dual nature. It can be calculated, it can calculate something, but it can also be treated simply as a list of symbols. So since they are all function, it doesn't make any difference. It doesn't make any distinction between program and data. So they are all functions. So it can be a function to calculate something, and then it can also be a list of symbol. So the fact that functions are also lists make it easy to implement program that create other program. So we can say list is a kind of a programming language that creates other program, or that implements other program, that analyze other program. So it's a kind of programming language that creates another programs, or that implements another program. So the 11 things to know is that Lisp evaluation is easy to understand. The Lisp evaluation is easy to understand. The first is it will read in input, then it will evaluate it, and then it will print out the result. Finally, it will print out it will print out the result. So finally, it will print out the result. So it will read first, it will read the input first, then it will evaluate it, and then it will print the answer. So Lisp evaluation is easy to understand. So the reading and printing steps are simple to understand because they are both visible in the Lisp windows. They are both visible in the Lisp window. But what does it mean for Lisp to evaluate an input expression? There are 4 basic rules we need to know. When you want to evaluate input expression in Lisp, there are 4 things to know. And remember, your evaluation starts from the left to the right. The evaluation starts from the left from the right. If you look at our contemporary programming language also, the interpretation or the evaluation comes from left to the right. It comes from left to the right, and that's the reason we have what we call, I usually call it PEMDAS, parentheses first, exponential follow, division or addition, division or multiplication rather, sorry, and then addition and subtraction. So I normally call it PEMDAS. It's an acronym I form. A lot of people formed it. It's not like I'm the one that formed it. I didn't form it, but that's how I got to know about it. We call it PEMDAS. I got to know it. So the first thing is that you evaluate parentheses first. That's how I got to know it from my programming life, or since I became a computer science student. So parentheses first, then exponential follow, then multiplication and division follow, then addition and subtraction. Addition and subtraction in that order, from left to the right. From left to the right. So anyone that appears in this order from left to the other, from the left to the right, is being implemented first. And that's the reason, if we are looking at it critically on our own, we may make mistakes. Let's say, for example, maybe we have something of this nature. I don't know. I want somebody to interpret this thing for me. I want to know whether you get it right. 2 plus 8 minus 2 in a bracket, then multiply by 4. Who can help us to evaluate this, and who can give us the answer? If you know the answer, just type it on our chat room, on our chat group there. Let's see whether you can get it. Let me show you the question again. 2 plus 8 minus 2 multiplied by 4, then is in the list already. Open a bracket, open bracket, 2 plus, open and close another bracket, 8 minus 2 inside, then multiply by 4. Who can evaluate this for us and tell us the answer based on what I just explained to us? What should be answer?
26.
20 what?
26.
26. Okay, is it okay by everybody? Is it correct? Is the guy correct? Charles told us that he's 26. Is it correct? Theo, are you sure? Brendan, you sure that Theo is correct? Are you sure? Are you sure it's correct? I want us to talk. Okay, not sure. Okay, good. You are not sure. Anybody that is not sure again? Anybody that is not sure, can you tell us your own answer? Okay, you are sure? So it's only Cup that is not sure. So the answer is 26. And how do we go about it? I told you, if you look at pendants, parenthesis first. So you go back to the question. The question says, you can see the question. So the first thing we are going to look at is the parenthesis first. So 8 minus 2. 8 minus 2 is the first thing we need to do. So if you want to evaluate this, it's going to give us something of this nature. We are going to have this. And that's how LISP evaluate. So we are going to have something like this. Plus. So instead of, but if we are going to write it in LISP, there are better ways to do it. But I'm just trying to do a kind of an evaluation process now. So 8 minus 2 will give us 6. Then multiply by 4. And then we close the bracket. Then the next thing we need to look for is to check which one comes first again is multiplication. So this one can I be equal to like this? 2 then plus 24. So with this we can now have our final answer to be 26. We can have our final answer to be 26. So this is how an evaluation is being done in LISP, and it's very understandable. We can easily understand it. So let's see how it goes. So we have 4 simple rules that we need to follow. So the rule 1 is that if the expression is a constant value, a value that cannot be changed like a number, then LISP return that value as a result of the evaluation, and no more rule to apply. So a common constant are numbers, keyword, strings, and anything that's preceded by a single quote. These are constant value. So the rule 1 is that if you have such an expression in LISP, just like this, it will just evaluate it and nothing more. You just do like this 4 and press enter. Sorry. Okay, still showing our previous work. But what we are trying to say is that here we are talking about constant now. 4.5 is a constant. Hyphen programming is also a constant. I, common word inside a double quote is also a constant. So there are numbers, keywords, or strings. So we want to say that if the expression is a constant value, a value that cannot change like a number, then LISP return that value as a result of the evaluation, and no more rules is applied. Then number 2, the second one is that if rule 1 did not apply and the expression is a symbol, then LISP treat it as a symbol as a variable, and no more rules is considered. For example, when we define a variable to be s, when we define a variable to be s. And then if the variable has a value, then Lisp return the value as a result of the evaluation. It return the value as a result of evaluation. Here we have defined variable s as 10. So it will return the value of that s. It will return the value of s, which is 10. It will return the value of s, which is 10. And then if the variable does not have a value that is unbounded, then the Lisp signal an error and wait for the problem to be fixed. So that's rule 2. That's rule 2 for us. And then the rule 3 is that if rule 1 and rule 2 did not apply and the expression is a list, then Lisp treat it as a function call and no more rules are considered. That is, the first element in the list is assumed to be a Lisp function. The rest of it is list. If anything is assumed to be data for the function to use, and if no error are found, then the result of the argument evaluated are passed or applied to the function. And if the first element of the list is not a function, if the first element of the list is not a function, then an error is signal. And then rule 4, if rule 1, 2, or 3 do not apply, Lisp signals an error and wait for the problem to be fixed. So there are 4 rules we must know when we are trying to evaluate when Lisp is evaluating the program. And then the 12 things we need to know is that Lisp is easy to learn. There are almost no syntax rule to remember. No need to declare anything. No need to compile. No need to understand the details of the memory management. It is very easy to learn. And how to study and program in learn? Read the first few chapters. Okay, if you can read any chapter the first few chapters of the introductory Lisp of book, you'll be able to get everything about Lisp. Because it is very easy to learn. And then the number 13 thing you need to know is that it is a major AI language. Alongside with Prolog, C++, and Java. Lisp is one of the 4 major languages used in AI, an alternative to Java and C++. So its performance comparative to C++ in terms of speed, development time is lower, less variable compared to Java and C++, and then memory consumption comparable to Java, because they are machine dependent language. So it is a major AI language. So before we go further, we look at the symbolic expression and Lisp data. We'll just look at it one after the other so that we'll be able to use it to answer some of the questions we need to answer, because we still have a tutorial class that the tutorial question that you are going to solve on your own. So we can simply look at some of the expression, the way we form the expression, so that when you are when you are doing your assignment, it will be very easy for you. So the first one is that Lisp expression is called a symbolic expression. It's called a symbolic expression or S expression. It can be an atom, that is a list or a collection of S expression enclosed by open and close parentheses. So we have 2 types of symbolic expression. We have atom, then we also have list. So an atom is an individual thing like a number of symbols, and list is a group of things. So you can see it here. S expression, we have atom, we have a list. An atom can be a number, which can be integer, ratio, or float, or it can also be a symbol which is keyword, or your S expression can be a list, and these are the integers. An integer is a counting number like 1 to 1, 0, that is 1, 0, or 99 or negative 99. It can be digit, can be preceded by an optional, which is a positive sign or a negative sign. It can also be a special prefix like #s to be hexadecimal radix, #0 to be octa, #b to be introduced base 2. And some example of integers are 0, negative 99, 1000000 to read well like that, 33, #s fff, #b 111000. So these are example of integers. These are example of integers. Then we have ratio. A ratio is a proportion or a ratio of two integers. For example, 1/3, 1/3, 1/3, and 1/2 rather, or negative 3/2. So automatically reduce the ratio to their simplest conical representation. For example, 2/4 will become 1/2. 6/3 will become 2. And some example of ratios are 1/3, 1/3, 10/2, negative 3/4, #SA/B. So these are some of the ratio. Also, we have floats. We have floats 0.0, 100.01, negative 0.5, 4.3e plus 2, which is 4.3 times 10 raised to the power 2.111 to the power 2, or 6.3e negative 10. So these are floats. These are floats. Then we also have symbols. We have symbols. A symbol is a sequence of alphanumeric character. Symbol that can be taught as a word. Symbols can be constructed from letters, digits, and hyphen. So LISP is case insensitive. So it doesn't matter it does not matter. It is case insensitive. So we can have some of the examples are hello, 12 tone, C sharp minor, C hyphen sharp hyphen minor, and keywords is a special type of symbol that starts with a column. So if you want to have a column, if you want to have a special keywords, so example of keyword is column SSSH hyphen, column retrograde inversion, column the longest, the keyword IV ever type. So these are the keywords, because when they start with column, you know that is a keyword. So we also have some special symbol like T and nil. The symbol T and nil represent a Boolean value, a Boolean value, true or false. So when you see a T, that means it's true or yes. When you see a lin, it means false, no, or empty. So lin is both as a symbol and as a list. So when you see a lin and open bracket, left and right parentheses also mean same thing. So when you have lin, maybe you have left and right parentheses, they are all mean the same thing. They all mean the same thing. So when you see T stands for true or yes, which is a Boolean value. It stands for true or yes. Or when you have a lin, it stands for false or no or empty. Then list. So a list is a order. So the content of a list are called its element. Any type of data including list can be put in a list. So any type of data can be put in a list. So when you have a list, the content of such list are element is called is element 1, 2, 4, 0, T-7. These are elements of such a list, and we can also have a list inside a list. So a list notation is that the left parenthesis mark the start of the list, and then the right parenthesis mark the end of the mark its end, and space are used to delimit the element inside the list. So you don't use comma. You don't use comma. We make use of white space. You just press a space, and when your list have no element, you just have open and close or left and right parentheses. So such a list does not have any element. Such a thing does not have any element. And then we talked about the element of ellipse. So we have accuracy. Say how large a number can you represent in ellipse? You can discover this. You can have it 0.00798 minus 10 or negative 10, 3.45678. So we have fraction also as part of the element. So we have 3/5, negative 18/19, 22 divided by 9, 44 divided by 11. And then we are still talking about element of this. We have numeric procedure. That is a function s is written as f, which is standard as a function of s, open the bracket and then put f of s, and then you can truncate it. When you want to truncate, you have the left parenthesis backslash and then 17 and 4, and then you close it. So we have a list inside a bigger list. Here you can see that we have a list inside a bigger list. So we have two lists here. We have the bigger list, then we also have the sub list. So round up also, if you want to round up a number, you can have this mode, we can have this GCD 9,87. Then you can see this just like the expression I showed us. Then this one has to make use of a pendant to look at the evaluation, which one comes first, which evaluation are we going to do first, the one in parentheses first, and then look at some of these operators that come first before we finalize the evaluation. And then we also have symbols. A symbol is a sequence of characters, e.g. I, 2, just an hyphen a, an hyphen symbol. These are just a symbol in Lisp. Then it still continue. We have a list, 0 or more element enclosed in the parentheses. Element of list that can be of any type. When we have this, they are all elements in the list. And then we also have what we call a mathematical operation. Operators, we have mathematical operations, like if you want to add, you want to perform division, you want to perform exponential, anything you want to do is possible with Lisp. And the most important thing is that you need to declare the value of s first before you can carry out any operation on it. So these are the things we need to know about Lisp. These are the things we need to know about this. And today we have an experiment, we have an assignment we are supposed to do. So we have exercise. We have exercise that we need to do. So we have exercise that we need to do a symbolic expression and leaf data. So I may just try to do one or two for you, and then you continue on your own and you submit your reports, just like what we said earlier. Let me go back. I want to exit. Then let me restart it. I hope you are together. Are we together? Are we together?
Yes, sir.
Okay. Good. So I have this
Yes,
now.
sir. Yes, sir.
So like now, the first thing talked about number. We want us to evaluate number. So how do we go about it? Come in, let me let the okay, it's still coming. Okay. So like now, I have my operator. One. Sorry. It's like my bastard is not working or not. So C plus 1 4. So let's see the answer. We can see it now. When you want to add numbers together, maybe you want to multiply number 6 and 7, 42. So like the first expression says that we should do that. So you see, write a common LISP expression to evaluate numbers. So we just did that, and based on what we talked about, we should be able to handle the remaining one. Like, let me try to do something about this function. I want us to look at the function sine s, but we need to define s first. So let's say like this. Let's say define variable s to be 10. Let's say like this, to be 10. Then let's now say sine s. We want to evaluate sine s. You can see now sine s, which is sine 10, is negative 0.544021. Negative 0.54.021. Like if you want to find cos s now, you just say cos s, because we've already defined s already. What you just need to do is just to do like this. It will give us the value for cos s. If you want to find the tangent of s, what you just need to do is just to say tan s, and then we'll close and do like this. So this is the first thing we need to do is to make sure that we define the value of s before we begin to do other things. So I will give us time to work on this, and then I look at it, then we can also look at it together. I will see your answer, and then we'll look at it together. Is it clear? Are we together? Hello, are we together? Today we are just trying to lay the foundation on the LISP programming. So Did you see some of the program I ran last time, like this? One plus 1, that is 1 plus 4, but it is multiplied by 7, and then when I want to look at the sin s, cos s, and tan s, the first thing you need to do is to define your s. So we use this line to define the s, and then we now begin to carry out the evaluation sin s, cos s, and tan s. So I was able to give us the answer. So I want you to go over this expression, over this exercise, and see how we can be able to solve it. I will give you time to go through it, then we can come together to solve it together. I'll give you 10 minutes to go through it, and then we come together to solve it. Is it clear by everybody? Is it okay by everybody? Are we together? Hello, can you see my screen? Hello? I hope you can see my screen. Hello?
Yes.
Can you see my screen?
Yes.
Okay.
Yes.
So you saw all
Yes,
the
We can
program.
see your screen. We can see your
Now
screen.
we can see you.
We can see your screen.
Okay,
Yes.
you saw the program I just ran. This one. Did you see it? This.
Yes.
Okay. So now I want you to do this exercise. I will give you 10 minutes to come up with something like. We've done the first one. Can you go over this? Strings, symbol, function, list, and then try to do other ones like that. Can you try? Can you try? Can you try?
So we
Yes,
want to do
yes,
question
yes.
1 or question 1 to 4?
Yeah, question 1 to 4. Yeah. Meanwhile, while we are doing that, I think we need to take our attendance. Let's take our attendance. Sorry, my system is a bit slow. While we are waiting for the QR code, I want us to begin to solve the problem. While we are waiting for the QR code, let's begin to solve the problem.
sir, after class, can I meet? Can I stay back? I want to ask you something.
Okay. No problem. QR code. This is 1C, 1A, 1B. Okay. So, can you see the code now? You can mark your attendance now. Hello, class. Kindly mark your attendance.
Yes, sir, we can see it.
Kindly mark your attendance now.
Yeah, we can see, sir.
Okay.
Hello, sir.
Yes?
Hello, sir.
Yes, I'm listening.
I want to ask what is the difference between string and symbol?
Okay. Okay. You know, when you're talking about strings, if you look at this thing I show you, sorry, if you look at the symbol, I told you that a symbol can be constructed from letter, digit, and hyphen. And that's this you say hello, 12 hyphen tone, and light. Can you see it like that? So a symbol is a sequence of alphanumeric character. Hope you're getting me. Is it clear? Hello?
So you mean
Are you with
if
me?
no alphanumeric, so it is a string.
If it is just ordinary letter, if it is just ordinary letters, they are strings. Is it clear?
Oh, okay.
Hello?
Thank you, sir.
Yeah.
Okay,
So
okay.
when you
sir.
have alphanumeric being put together, it becomes a symbol. And that's the reason in the definition here you say a symbol is a sequence of alphanumeric character. A symbol can be taught as of words. Symbol can be constructed from letter, digit, and hyphen. Is it clear now?
Yes, clear.
Okay. Okay. So like now, if you now have strings in quotes, when you have words in quotes, hope you are getting me, they are strings. Is it clear? In double quotes, maybe you put hello in double quotes, it's referred to as strings. But a symbol is a kind of a combination of letters and numbers. Is it clear now? So because when you have something like this, just like this, can you see this? Just hyphen a hyphen symbols. This is a symbol. You can see that I also is a symbol. 2 is also a symbol. But when you have it inside a quote, is it clear? It becomes a strings. Did you get me? Is it clear? Like now, when you have it like this, can you see my screen? When you have it like this, something like this, it becomes a strings. Did you get it now? Because at this point, is no more a symbol. It has become a strings. Just like this now. If you look at this, this is a string. It's not a symbol. So a word in a quote is a strings. Is it clear? Are you with me? Hello? Are we together? Are we together? Hello, class? Hello? Are we together? So, what I'm trying to say is that when you are talking about a symbol is formed out of letter, numbers, and hyphen. But when an ordinary letter is being used or is being put in a quote, is known as a strings. Is known as, sorry, I lost my connection again. We are all taking our attendance, right? I hope you have scanned in your QR code. Hello, class.
Yes, yes.
Okay, good. So,
Yes.
please, I will want you to complete the exercise and send to me, or you give it to me in our next class, which is next week Wednesday between the hour of 8 p.m. to 10 p.m. So you submit the assignments. Okay, you want me to share the code again, a Q code again? Okay. I hope it has not expired yet. Let me share my screen first. Can you see it now? Let me quickly share my screen before it expires. So, but you have to be fast because it's expire in the next 1 minute. The Q code expire in the next 1 minute. Can you see it now? Hello? Can you see it?
Yeah, now can, sir.
Okay.
Yeah, now can see,
Okay, so
sir.
quickly do that. Quickly do that because it's expired in the next. Okay, done. So you give me the exercise in our next meeting by Wednesday. I will give you the email address to send the exercise to. Is it clear? I'll give you the email address to send the exercise to. So any question?
Yeah, regarding the submission. So the method of submit the assignment is in the screenshot form or the file.
No, make it a file. Make it a okay, because of the programming aspect of it, you screenshot. Do a screenshot and you place it in a in Word document, so you can generate the PDF. So I'm going to give you an email address where you are going to send the PDF to.
Okay, understand. Thank you, sir.
Okay, any other question?
No, sir.
Okay, then we meet again on Wednesday next week. Thank you. Bye for now. You submit next week, not today, not tomorrow. You submit next week, Wednesday. I will give you an email address which you are going to submit to. You just convert all your screenshot to PDF and then you send to me. So bye for now. Yeah, you submit in the class. You submit in the classroom. Yes, you submit in the classroom next week. You submit in the classroom next week, Wednesday. between the hour of 9 p.m. between 9 p.m. Between 8 p.m. rather, sorry, 8 p.m. to 10 p.m. Then I'll also ask the coordinator to help me put it on your MMLS so that you'll be able to know that we meet next week Wednesday by 8 p.m. to 10 p.m. So I'll put it in MMS. I'll ask the coordinator to do that for me. So bye for now. Goodbye. Meet you next week Wednesday. Bye.